Okay, everyone say hi.
Hello.
Okay, so directions. Construct C equals A plus B by drawing and calculating the direction and magnitude of C. The direction should be measured from the positive x-axis. So what we're going to do first is we're going to just label our positive axes. So I'm going to say that this will be our positive x, and then this one up here will be our positive y. And so when it says C equals A plus B, C really is just the resultant. It's our resultant. I know in class I've been using R, but it doesn't matter. They're just random placeholders, right? There's variables. So what we basically want to do is we want to add A and B together. And so what's kind of nice is these are constructed in such a way where you can break them down into their components a little bit more easily. But technically speaking right now, these are not in their added form, right? If you want to add B and A together, we need to take all of B here and we need to place it on top of A. So for example, if I did something like this and I drew, oh, that is not the vector I wanted to draw, but it's okay. For some reason, my computer makes these gigantic vectors, but then when I like slightly erase it, let's see if it works. It like disappears for some reason. It's very weird. Oh, now it's like that. That's sad. It's okay. Let's go back to here. Perfect. So we can take vector B and we want to basically add it over here, right? Not a perfect intersection point right there, but it's okay, right? So vector C then is going to point something like this, right? From start to end. And so the reason why we break things down into components is so that we can add up the horizontals, add up the verticals, and that'll give us two components of C, right? It's actually going to give us this vertical one right here and this horizontal one. So this all looks really messy. So let me erase all this. What we're going to do, sorry, is we're going to just first break down A. We're going to break down B. We're going to make a chart. We're going to get what their components will be when you add them all up. And then we'll remake C. So let's do this. So let's just draw our triangles. So I'll make all my horizontal ones blue. And then I'll make the vertical ones red. And then I'll make this vertical one, I'm going to call it AY. This other vertical one will be called BY. So we'll be called AX, and this will be called BX. Right? And so we're basically just going to want to find the components and add them up. So first thing I'm going to do for organizational help, I guess, is I'm going to make a chart. And this chart's going to include A, B, and C in it. So I can do this. We'll do it right here so it stays real close. A, B, C. C, again, is our resultant. And then we're going to have the X components and the Y components. So pretty easy. We're going to start with A. And so if we're looking at it, right, our opposite side is AY, and our adjacent side is AX. If we want to find out what those values actually equal, all we have to do is take the hypotenuse, 8.0, and luckily for us, it's actually really easy. A 45-degree angle means that the sine and the cosine are going to actually equal the exact same thing. But just for doing it once, I'm going to calculate them both anyways. So for AY is equal to 8 times sine theta, which is 45 degrees. And if I just type that into my calculator in degree mode, right? If you're in radians, you're doing it wrong. You get 5.65, so we'll just say 5.7. That's fine. We don't have any units for this one because we're doing like a mathematical version of this. For AX, we do the same thing, but with cosine. And luckily for us, cosine of 45, sine of 45, of course, is the same. So we get 5.7 and 5.7. But now, what we need to do is we need to go back and look at which one of these is positive and which one of these is negative. AY points upwards, so that's our positive direction. So we can put that in, positive 5.7. AX, though, is pointing in our negative X direction. So we just add in that little negative sign there. We get negative 5.7 here. So we finished one part. Now we can also do B. Whoa, just zoomed out for some reason. So we do b. And kind of the same way, the sine is going to represent the opposite side, which is our vertical. So by is equal to 4.5 sine of 60 degrees. And then our bx is equal to 4.5 cosine of 60 degrees. Cosine, in this case, is 1/2. That's just like a trigonometric identity, I think. So that's going to be 2.25. So 4.5 times 1/2, 2.25. Sine, I can't do that in my head, so I'll just write it out. Yet we'll say 3.9. And then we look at it. By points upwards, so that's positive. Bx points to the right, which in our case we denoted as the positive x. So we just have positive 3.9. Oh, no. Let's see here. Positive 2.25. There we go. This one is positive 3.9. And so I'm just going to add these all together. So negative 5.7 plus a positive 2.25. It's going to give us a negative 3.45. And if we have 5.7 plus 3.9, get 9.6. Now I've already been rounding like a bunch. So you might get some answers that are like slightly different, but as long as you're close, that's good. So what we have here now is we have cx and cy, right? So remember how I drew that vector? It was like somewhat like this, right? So it looks like something like that. We now have the components of that vector, right? So what we can do instead is I'm going to just draw another little mini diagram. So we'll draw it, we can draw right here, right? Just go like that. And we're going to go negative 3.45. So that's to the left, about 3.45. So I'll just draw, just eyeballing it. This is 3.45. Notice I don't have the negative anymore because the arrow represents that. And then I'll go up 9.6. So I probably don't have enough room, so I'm just going to do something like this. Remember, this is cy. This is cx, right? And then I'm going to draw the resultant. This c. So I just wanted to show you kind of, I want to go back and review exactly what just happened. The question was we need to add a plus b, right? A plus b is going to equal c, but they're vectors, so you can't just add them linearly, right? We can't just do a plus 4.5. That's not going to get you the right answer. So what we did, since they're at weird angles, is we broke them down into their components, ay, ax, bx, and by. We added the horizontals together. In our case, they subtracted out. We added the verticals together. And what that did is that gave us two components, a vertical one and a horizontal one, that represent the components of C, right? So if I add this A plus this B together, I'm going to get C. But also, if I add CY together and C to CX, you also get C, right? So what I basically did is, if you can imagine, if we're doing like a normal math problem, I asked you this yesterday, right? We know 3 plus 2 equals 5, right? But also 4 plus 1 equals 5, right? We changed the problem to become something that was like a little bit easier, right? So technically now we're solving a different problem, but it's getting us to the same solution, an equivalent solution. So now we can just use Pythagorean theorem, right? We can solve for C. So I'm going to write that down. So the Pythagorean theorem is a squared plus b squared equals c squared. We take the square root of all of that. We just get the square root of a squared plus b squared. Keep in mind, order of operations, you need to square those values first, add them, and then you can square root them. So let's put them in. I have 3.45. Even if I put in negative 3.45 here, you'd still get a positive number, right? So keep that in mind. If I had negative 3.45 squared times negative 3.45 squared, you get a positive number. Plus, ooh, that's not right. Ooh, still not. There we go, 9.6 squared. And then I take the square roots. And so I'm actually just going to type this into my calculator. Let's see here. So we have the square roots. We get 10 0.2. Again, no units because this is just like a math problem. There's no units attached to it. In real life, though, you'd need units. So many of you might think we're done. We're not. We're not, right? Because this is just the magnitude. We need to find the direction as well. And the direction includes two parts, your angle, but also your frame of reference. Right? And you're gonna be like, what's frame of reference? We'll talk about that when we get there. So we made this triangle, so it makes the most sense to find the angle from right here to right here. Right, this is theta. And I'm just gonna use sine to do this. So all I'm gonna do is I'm gonna write down my sine function, sine theta, and that equals opposite over hypotenuse. So opposite is 9.6. Our hypotenuse is now 10.2, we just found that out. And now I need to get theta by itself. And we do that by taking the inverse of it. So if I do theta here, I have to take the inverse sine of the other side. And again, remember, degree mode. All right, so when I do this, looking at what I kind of have for my components, it should be a pretty big angle, right? It should be definitely over 45 degrees. So let's check it. We get 70. I got 70.23 or 25. So I can say 70.3 degrees. And we're still not done because we have to choose a frame of reference to measure from. So I'm going to write down what the full answer is, and then I'll tell you why it's that. So our full answer for C is 10.2, 70.3 degrees north of west. And so common questions. Why isn't it northwest? Well, northwest means exactly 45 degrees, right? So if you had an angle that was pointing in C's quadrant at exactly 45 degrees, you could just say northwest. You could say 10.2 northwest, and that'd be fine. But it's not exactly 45 degrees, right? So what we have to do is we have to kind of give us like a frame of reference. I could say north of west. I could have said above the negative x-axis, right? That gives a frame of reference, right? We're starting at the negative x, and we're rotating above it. We also know that this is the west. So when I do the north of west part, this is all it means. I started west, right? My angle started right here. Let's see if it, right here. And then I started going north of west, right? As the angle went up, right? Or even like my position right here at the top, it went from the west to north. So now I am north of west, right? If you were at your house and then you went north of your house, you would describe that direction by saying, I am now north of my house. If west was your house, we are now north of it, right? So now we're north of west. So you can do north of west. If I wanted to, I could have found this angle as well. And if I found this angle right here, that would have been west of north, right? Because we started north and then we went west. But for now, right, we'll do more of that later. As long as you have a solid reference point that tells the person reading your answer, I started at this axis and then I went towards this other axis, that's good, right? So that is all. Everyone say bye.